Okay, let's look at this first video about hypothesis testing. We're going to be looking at H0 and H1, my null hypothesis and my alternate hypothesis. H1 can also be known as HA for H alternative. Now this is null, N-U-L-L. For H0, you're going to see a hypothesis is a claim or a statement about a population, and a hypothesis test is the procedure, this H0 and H1, for testing a claim about a parameter or a population. And I think it's best to just look at a question to understand what this is, and we'll draw a normal distribution. And these are always normal distribution questions. So this question, a company produces metal rods, mean length 210. They could tell you something about them servicing the machine, and or maybe the machine has had an accident and they want to test whether it's gone wrong, or they could statistics questions, they bring in loads of words, but you can see very few numbers in these questions. So this question is, this is the machine. They test the machine to see, has this mean length changed? And they tell you that they take a sample of 100. So immediately you can see here, n is equal to 100. My mean is 211.5. My original mean is 210. So my new test mean is 211.5, and my standard deviation here hasn't changed between the two. It's 6. So we're asking us with a 95% level of significance or at the 5% level of significance. There's two ways these can be phrase, 95% confidence level, and many other ways they can phrase these questions. But a hypothesis test. So what is H0 here? H0, we have to state it, is always that the situation hasn't changed. The mean length is 210. We're saying this situation is still the same. Mean length. You could write just H0 210 centimeters, but write it out. Mean length is 210 centimeters, and H1, I just write H1 mean length not 210 centimeters. Evidence to suggest that it has changed. That's what we're going to look at here. Is there evidence to suggest the mean length has changed? So we're doing what we did in population proportion. We're looking at x bar minus mu divided by standard deviation over root n to give me a score here. I've got a sample of 100, so that's my n. I'm testing 211.5 against a population average of 210, my sample average against my population average, and I'm dividing that by standard deviation divided by the square root of 100. So that's going to give me square root of 100. 1.5 on top times 100 is going to be 11.6. It'll be 1.5 by the 10 divided by the 6. 15 over 6, 2.5. Now, what is this 2.5? This is where we're bringing in our normal distribution sketch. So you all know this already, what this 2.5 is. This 2.5 is 2.5 standard deviations away from here, going in this direction or in the negative direction, depending on which way we're looking at it. So 1.96 standard deviations is my 95% confidence interval from when we looked at confidence intervals, 1.96. So if our result is outside this 1.96, so you say as 2.5 is outside plus or minus 1.96, we'll call standard deviation. I'll just change that. We could say plus or minus 1.96 standard deviations. So as 2.5 is outside this, what we'll call also a critical region, we can say, therefore, we conclude it would have to be inside here to accept H0. So we can conclude that the mean has changed. Now let's look up 2.5 and determine what's going on with this p-value. So score 2.5, and that's going to give 0.9938. So what is a p-value? So a p-value, if you want to look at it like this, our p-value are these two tails added together. That's my p-value. Now we said it needs to be 95% in here to accept H0. So if we get our two tails, our p-value, and it's less than 0.05, we can also reject H0. So our two tails added together need to be greater than 0.05 for us to fall inside this region where we would accept H0. So let's look at our tail here. 1 minus 0.9938, 0062. Now what we say is there's two tails here, so we're looking at the bit in the middle. So we're looking at it's like the modular bar, the positive and negative version of this score. So let me just move over here, 0.062062 times 2, 4, and that's going to be 12. You can see here there's 1.24%. Another way to look at it, which is less than 5%. Therefore, reject H0 will be another way to approach this hypothesis test. There's a few methods that are acceptable. You can look at your p-value. Instead of looking at this, is the 2.5 inside or outside? Go straight to your z-score. So that's a kind of little introductory to hypothesis testing. And we'll look at this topic through question answering in the next couple of videos.